Всем привет! Давненько на планете CAM не было материалов по аддитивному производству. А ведь тема не теряет актуальности. Напротив, аддитивные технологии, в том числе 3D-печать металлом, становятся совершеннее. И что не менее важно, дешевле. В общем, я решил достать из архива одно неопубликованное интервью с NC Kishore, сотрудником Dassault Systemes, отвечающим в компании как раз за аддитивное производство. На протяжении последних 5 лет коллеги из Dassault любезно приглашали Планету CAM в моем лице на свою большую ежегодную конференцию 3D Experience World. 2022 год не стал исключением. Мероприятие должно было состояться в начале февраля в американской Атланте. Мы уже даже согласовали поездку, забронировали отели и билеты, но в последний момент организаторы из-за коронавирусного омикрона изменили формат конференции на виртуальный. При этом предложили взять интервью по интересующей теме у одного из руководителей или специалистов Dassault. Я выбрал NC. Ну а в конце февраля, когда интервью уже было готово, вы сами знаете, что произошло. В общем, наш диалог записан и здесь воспроизведен на довольно простом и понятном английском. Для тех, кто совсем уж не владеет английским языком, постараюсь в ближайшее время подгрузить субтитры на русском. Приятного просмотра!
Hello, NC.
Hello.
So thank you for agreeing to this interview. You have a very interesting name. NC means numerical control.
That's one of the first questions any customer or any interviewer would ask me. But coincidentally, no. NC it stands for my native place and my dad's name, and then my first name. So it is by short it's NC, and coincidentally work with NC machines.
Okay. So our Planete CAM magazine is dedicated to digital manufacturing and the role of CAD/CAM systems in the modern manufacturing process. I know that you have been with Dassault Systemes for 25 or 24 years. No doubt the company is one of the world leaders in design and manufacturing software. Please tell us about how you started your career in the company, what path did you go through, and what are your current responsibilities?
So yeah, it's a long history with Dassault, and it's basically the passion for digital manufacturing that keeps me going. And before Dassault, I used to work for a German company. We used to manufacture grinding machines, grinding wheels, and I was hands-on with oil in my hands. But yeah, and then I switched over to Deneb before Dassault bought over Deneb and Delmia. I was working as a sales engineer or an application engineer on the machining products, on the machining solutions we had. At that point, we just had a simulation tool. That's it. We did not have any programming tools. So then we slowly transitioned. Dassault, they bought us over, and then we had CATIA. And I went into programming, and then I was managing the machining solutions. I was a solution manager for machining for quite a number of years, and then I was in the competency center supporting the customers and defining best practices and market conditions and so on. And then I moved on to R&D. That's where I am right now. And I'm managing the roles. I'm the senior portfolio specialist, managing all the roles for Delmia and on the fabrication side, which includes both machining as well as additive manufacturing. And
Are you located in the US?
Yes, I'm in Michigan in the US. Yes. Yeah, mainly I've always been hands-on. I've always been working with the customers, of course, with our R&D teams, understanding the customer requirements, the market requirements, and then supporting our development process.
Okay.
Yeah.
So what is the fundamental difference between additive technologies and traditional technologies? What are the practical benefits of additive manufacturing?
Okay. So traditionally, you know, we always had to machine or remove material to add value to a given part. Okay. And it takes time, it takes a lot of technique, it takes a lot of programming, it takes a lot of machine time, and it takes a lot of cost, tooling on how to hold the particular stock part or whatever before you machine it. Now, additive manufacturing is nothing really new. It's been there for a number of years, 20, 25 years. It's been there for a long time. And now I think it's coming mainly to the mainstream because of the advantages of the machine, the advancing of the machine technologies that we have right now, the number of tools that are available to define the additive paths, the laser paths, and also the cost, right? There is no tooling cost. There is no tooling fixture to hold anything. You're basically building the part. And that's one of the key advantages. The cost is one advantage. Now, one of the slightest disadvantages that used to be is the time it takes to produce a part. But I think as the technology is progressing, machines are becoming much faster. There are 8 different additive techniques that we know of right now, from powder bed to extrusion to light immersion. There's so many technologies, right? And I think the powder bed is kind of proven to be more of a replacement. I wouldn't say replacement to a traditional machining, but it's trying to take over because of the fact that engineers can be more creative in the way they design components right now. They don't have any restriction of how is this part going to be manufactured or machined or held on the machine tool. Now they can think out of the box. The parts can be organic, it can be any shape, as long as it satisfies the design intent, it can be of any shape. So a result of this additive manufacturing progress is the fact that the parts are more attractive, are more organic, and it's more lightweight. You can remove a lot of material. You don't have to have all the extra material there. So thereby, the parts are going to be lighter, and wherever these parts are going to be used in, whether it's turbo machinery or airplanes or automotive, it's lighter, which means more efficient. It's more beneficial for the environment, and there are a number of benefits that kind of has this domino effect on additive. So there are also robots right now printing, and we are getting into that. We support robots, printing of robots, and additive is not traditionally need to be metal based. It can be extrusion, extrusion could be plastic, or it could also be concrete. There are robots dispensing concrete to construct buildings. So I think it's got a very solid future going forward, and I think the traditional technology will still continue to exist because there are components where you simply cannot go away without machining it. And in fact, even for additive, once you print the part, you have to post-process it. You have to machine it to get to the perfect finish, especially in metal. So I think it's kind of going to have a good balance, but I think additive is going to have a little more weight because of the reduced cost, and as the machine becomes more efficient in terms of printing, I think it's going to have a lot more weight.
What is your favorite technique? You said there are 8, but what is your favorite?
I've worked on machining for a lot more years than additive, but I think additive is a lot more cooler because of the fact that you can produce things, you can see it printing, and I think it's there's nothing favorite as such, but I think it's more curiosity in what else can we do with additive, how fast can we do, and Does it really replace machining? I don't know yet, but there's nothing really favorite as such. But traditional machining is something really cool to see when you sit on an airplane and you see parts that are produced with our software, because 99% of the world use CATIA for machining and for designing. So I think it's very interesting on both sides of the technology. So it goes hand in hand for me.
Okay. So in your opinion, additive technologies are the engine of the production revolution or its consequences?
I didn't quite hear the beginning of the question again.
I mean, additive technologies are the engine of the production revolution, of revolution in manufacturing, or its consequences? Okay. So
yes, okay. So I think
what is the first? Yeah.
As of now, you see there are printing farms in China or in South America or in Thailand or wherever it is. They're printing farms that you can sit at home, design your component, put it onto the marketplace. Let's say in our place, Dassault Systemes marketplace, and you can bid. It's e-commerce friendly, so you have access to literally hundreds of producers sitting anywhere in the world, and they can give you a price, and you can print the part, and they can print the part and ship it over to you within a couple of weeks time. So you are getting what you really need, and it's also competitive because there's bidding going on. So they want to get their business. So I think in that way, I think on the extrusion, polymers, plastic side, it's very efficient and it's very competitive. And as the technology evolution happens, it can be very powerful. But when it comes to metal printing, I think people would continue to still hold on to their IP because when you talk about metal, it has to be components that are it's moving components. So it's going to it is kind of having a replacement. For instance, if you think of a fuel injector, the whole fuel injector could be printed today, as opposed to traditional machine, and it's far more economical. I think as the technology evolves, it is going to have a more weight, and it's a matter of time, I think, when machines would be far more efficient in printing parts. Right now, you think of a small component with about 2,000 or 3,000 layers, it's going to take about 6-7 hours of laser printing. So it takes quite a long time, as opposed to machining, it could be done in a couple of hours. But when these things, right now we know machines that are quad laser machines that have 4 laser heads. You can print multiple parts at the same time, and you can also coordinate between which side of the part that it's going to the 2 lasers or 4 lasers can go print. So it can be a simultaneous printing to reduce the cycle time. So I think as the speed of producing additive increases, I think it's going to be a lot more advantages over machining generally.
So your answer that if I understand you right, so this technology, I mean 3D printing, it moves the manufacturing at home. It moves, correct?
Yes, it is completely a different paradigm shift, and I think it is. People were very excited just a couple of years ago, maybe 3-4 years ago. Everybody was coming in with these brand new machines, and then taking it into the mainstream for mass production. We had issues because the cycle time was not really, the cost of the material is lower, but the cycle time is still a disadvantage at this point in time. And that's why these quad lasers are and different techniques that are coming in, having a combination of metal, and also there are different alloys that they use for much faster evolution of the given part. So I think it is going to take some more time before it becomes mainstream. And even if it becomes mainstream, there will still be traditional machining to finish the component. And unless the 3D printing machines are so beautifully inaccurate that it is going to produce the final finished part, which I think it's highly doubtful, but there will be some finishing that's required after that, yeah.
Okay, so does Dassault offer products and solutions for additive manufacturing? And what's the company's strategy towards to this kind of technology?
Yes, Dassault has been one of the first companies to offer an end-to-end. We have always offered an end-to-end an enterprise solution, whether it's machining or additive manufacturing or design or planning or robotics. We always want to focus because our value is in bringing people together. And having a communication is key in this age, and I think it's very key to have everybody the same view of what everybody is doing. So clearly the 3D experience platform enables that. It enables concurrent engineering, it enables collaboration between people wherever they are on planet. And having said that, yes, Dassault has this end-to-end solution where we have the 5 pillars of additive manufacturing. So we start out from the conceptual stage of selecting the material for printing. And how do you even select the material? Is this the right material for this component? So we actually go into the molecular structure, understanding the molecular structure of the powder and how it behaves when this is printed. So even before we design the component, we look at whether this is the right material, and we use the BioVia set of technology for doing that kind of a study on the material types. And then that's the first pillar of that's why we start off from the conceptual stage, and then we take it in. Once the material is defined, then we take it into the design stage where we do this lightweight engineering. So we design components organically and try to the lightweight engineering. We want to reduce the weight of the component, keeping in mind the design constraints, and we come up with this beautiful design with generative design with CATIA. And again, all this on the same platform. We're sharing this information, and once the part is designed, we take that into manufacturing, which is where we have a set of tools from Delmia, whether it's powder bed or is it a hybrid. We take the design component and we slice the part, and then we generate the machine code. So we have tied up with a number of machine manufacturers like EOS, Renisha. We have these partnerships where we generate native code. Now, one thing in additive is true is that the machine manufacturers are not completely open to their IPs yet. Unlike the traditional NC controls, now anybody can generate an NC machine code. The G codes and M codes, and it's an international standard, and any CAM system can do that. But when it comes to additive, each machine has their own formats, and it's not a common format. It's not a unified format. There are consortiums of companies where even Dassault Systemes is involved in it to come up with this neutral format that we would like the machine manufacturers to embrace and support it and make it like a traditional NC code, but they're still not at their at this stage yet. So to counter that issue, what we have done is we are partnering with each company and having them support us with their specific IP, which is again restricted. So it's a partnership between the customer, the machine manufacturer, and us. And so yeah, so Delmia tools, we have the powder bed, we also support the hybrid, which is printing as well as machining, all in one single environment. We also support extrusion technique. And then I was talking about the pillars, and once we do this in Delmia, we take it into the Simulia set of applications to evaluate virtually the the build up. So we can analyze the heat, the stresses on the part, and if there's any issues that we don't like, we can go back and then redefine the process technique that we've used and then simulate it again. So we are virtually printing the part and evaluating its performance even before we print it on the real machine. And then once it's printed, evaluated, then we can take it to the shop floor. So we have this end-to-end solution for additive that many of the companies have understood our vision and are embracing it. The big, large airplane manufacturers have invested in our solutions and are taking a very close look. Yes, so that is what we offer.
Okay,
and all this on the platform.
You said about different formats and different manufacturers. What is your main partner?
Right now, we have EOS as the machine manufacturer. EOS as a partner. We have Renisha. We have Cincinnati BAM as one of the partners. Then we have 3D Systems. Then we have I forget the name. There are a number of manufacturers that we are working with as we continue. And this partnership is coming across when the customer has the machine manufacturer has the machine, and they insist that the machine manufacturer works with us, and that's when we tie up with the machine manufacturer and have this IP share that happens with us. Yeah.
Okay. So when home 3D printers became relatively mainstream, a lot of 3D printing software applications arose, published. Recently, we have seen that in classical CAM systems, support for the additive process also appears. Do you think this is due to the growing popularity of hybrid CNC machines? Do you see many hybrid CNC machines on a real production right now?
Yes, yes, we are coming across a number of machines. Like the Morisiki was one of the first machine manufacturer who came up with this hybrid technology. It's fascinating, while they print the part and also machine it on the same setup, which is really good. And we do support that technology currently. And just because we've traditionally been extremely good at CNC machining, and now with additive, so we do support the printing of the part and also machining on the same setup. Not only with these traditional machines, like for instance the Morisiki, for instance, we have the hybrid machine, but also with the robot that prints the part can also machine it on the same setup. So yeah, we are supporting those technologies, and as we go and as the market weighs in on what the requirements are, we are supporting this those things accordingly. Yeah.
In your opinion, what do you think? What is the main barrier for additive technologies right now?
In my opinion, what are the main barriers?
Yeah.
The barrier
the cost of the machine, probably.
Yeah, the cost of the machine. I mean, traditional NC machines, complex 5-axis machines, are far more expensive than the additive machines right now. They're far more expensive. But I think the main barrier for the industry to move on to the 3D printing side would be the time it takes to produce a part, and to be able to address their customer requirements in time, because of course they will save some costs in terms of tooling, but the time is something that they will have to be competitive with, and I think so that's one of the barriers, I would say. And the other barrier would be that for instance, right now, a large airplane manufacturer, they have our platform. Now, they have invested in a machine manufacturer for 3D printing, additive manufacturing. Now, that machine manufacturer may not be willing to open their IP to us. Now, that would be a barrier for us And for the customer, we have a common customer. The machine manufacturer and us have a common customer. But without having this IP handshake between us, the end customer would not be satisfied, and they would kind of might say, oh, Dassault Systems, you don't support this machine. You need to make that happen. We're not very happy with that. So that is kind of a barrier for us. So we want the machine manufacturers to be open to their IPs and then tie up with us, so that the end customer, so the machine manufacturer and us have a common customer. So we need to make our customers happy, and that's when this end-to-end solution that I was talking about will be a success, not just for us, for the customer, for the machine manufacturer, and ultimately for the environment we all live in. Yeah.
Excuse me, you say open IP, correct? IP?
Yes.
I mean,
yes.
Intellectual properties. What do you mean?
So the machine manufacturers have their own set of intellectual properties,
Okay.
which these are machine parameters for a specific
standards. You mean
not standards really. It's not a shared standard. It's the standard only for that machine, for a particular material type that they want to print. For instance, titanium or aluminum oxide or Inconel, when they print it on an EOS machine versus another a Renishaw machine, right? They have their own printing parameters that they recommend that is controlled in their machine IP. So we have these rules that are defined, and we don't know what those rules are. We have the ability to define our own rules as well, but the machine printing rules is what the IP is what we want to be exposed to, so that when we generate the code, we know what those parameters are. But again, we have come up with ways to work even without being exposed, but it could be just specific to a particular customer that we can work with. So yeah, there are ways to work around it, but I think it's a matter of time when we come up with standards, which by the way, we have a standard like the 3MF format. The 3MF format is a Microsoft format that there was a consortium of companies, Siemens, Dassault Systems, everybody, machine vendors were a part of it, but they did not want to embrace that widely because of this IP that they didn't want to share. They still have that competitive advantages between machine manufacturers that they don't want to give out. So 3MF is one format. There's AMF. There's 6 to 7 formats that we support in our software to output. There's one machine manufacturer like the HP machines, the 3D multi-jet machines, it uses 3MF format. So we output 3MF and they can just take it and print it right as it is. We also support the MTT format for Renishaw, the EOS print format, and yeah, for the AddUp is another machine that we support. So as we go, and we also have a neutral format, just like the traditional APT file. In NC machining, we have APT, which is a neutral file, and then it gets post-processed and generates a G-code. So similar to that, we have a NSP format, neutral scan path, which can be taken and post-processed for any machine as well. So we are kind of trying to become more neutral. Yeah.
Okay, thank you. I have a question about education. So how deep can American school children and students now dive into the world of CNC machines and additive manufacturing?
Yes, that's a very good question, and this is key because students are the future of manufacturing and the evolution of mankind, generally speaking, right? So I think it's very important that we support and we the universities we have a deeply discounted rates for them. It's just throwaway prices that they can use the entire platform for education kids. And we also, as you know, we have SolidWorks as one of our brands that basically has SolidWorks. People love SolidWorks, and likewise CATIA, and we are encouraging universities to take benefit of, and we have a number of universities who come to our traditional Dassault Systems shows, and they contribute and in demonstrating what they have done using our technology and how they have educated a number of they have this curriculum that they go through for manufacturing. So I think we continue to encourage that, and 3D printing now, I mean, you know, again, there's a subtle difference between the word 3D printing and additive manufacturing. 3D printing is more of a student, of a freelancer, or I want to have a 3D printing machine at home. I want to just print it just like a printer and make some fun looking parts and have some fun, as opposed to additive manufacturing, which is really industrial. So I think the students, the universities, the solutions are very affordable to them, and yeah, we are encouraging and supporting universities to embrace these new technologies that we have. And we also have this community, the Dalmia fabrication community. It's growing very fast, and we have industrial users, we have R&D, we have salespeople, we have you know, students, universities, and machine manufacturers. They have questions, they contribute to this, and we use that to share our new releases, new functions, how to tips and tricks, and we also have webinars. Even our product manager comes and delivers these webinars on a quarterly basis to share some highlights of what's coming in the future and how the solution is evolving. So I think this last year, this community has grown significantly, and it's continuing to grow. And while we expose our solutions to a lot more new venues, new markets, new segments, and come up with these key ways to, you know, how to help people educate the universities or the communities as we grow, and it's good for the industries as we progress into the future. Yeah.
Okay, thank you. And last but not least, you completed an MBA from Michigan State University, right?
Yes.
And I also now enrolled in an executive MBA course in my hometown, St. Petersburg.
Oh,
as
nice.
an MBA education, I think you help your career. And do you recommend such an education to our audience?
Yes, it helps in the way you think. Absolutely, how you interact with the customers. First of all, you build your own confidence, and the way you think and approach, both from a business side, an economical side, and as an engineer. So I think it's a good combination to have that. In terms of progressing in career, right? Yes, as soon as I did my MBA, you know, I mean, I had opportunities to go, but for my role and for my profile, it needed a lot more travel for me. And you know, with my personal family situation and so on, with kids and so on, I was not in a position to travel as much. So I also had the passion for digital manufacturing, and I continued to stay with Dassault. So yes, so it definitely helps your morale and stuff. But in terms of career, unless you move and look for new avenues to grow, if you don't have any constraints to do that, of course, it will definitely benefit you. Yeah,
okay,
absolutely.
Thank you very much for this interview. Hope to see you next year at Dassault conference.
Yeah, absolutely. And best of luck for your MBA, and have a good year.
Thank you very much.
Thank you.